Okay, so the topic is moment of inertia. See, what is inertia? Inertia is basically a kind of resistance. So if you want to move this mass, then you have to apply force on it. If you want the velocity of this mass to be more, you have to apply more force. So in translation motion, inertia only depends on mass. But in rotational motion, see, these two masses are moving with same angular velocity. But velocity of any mass in rotational motion depends on omega also and radius also. So both have same angular velocity, but velocity of both the masses and velocity of both the mass is same. So inertia here depends on mass also. The more the mass, the more torque you have to apply, and the value r. See, the more the distance of mass from axis, the more will be its velocity. So it means you have to apply more force. So in rotational motion, inertia depends on mass as well as distance of mass from axis of rotation. So mass is also important and r is also important. For this system, the inertia will be less because r1 is less than r2. Mass is same. So inertia in rotational motion depends on both mass and distance of mass from axis of rotation, while in translation motion, inertia only depends on mass. So how to calculate moment of inertia? Suppose we have a simple system where this is axis of rotation, this one, and mass is set distance r from axis of rotation. So moment of inertia will be I into mr square, and the distance that you have to take will be perpendicular distance from axis of rotation. Similarly, suppose this mass is there and the distance of mass from axis is r, but r is not the perpendicular one. This r is this distance. So moment of inertia, to calculate moment of inertia, you have to calculate the perpendicular distance from axis of rotation. So in this case, the moment of inertia will be mass into r sine theta, square of r sine theta. Similarly, in this system, now we have multiple masses. So axis of rotation is same. So for this m1, the moment of inertia will be m1 into r1 square. For m2, the moment of inertia will be m2 into r2 square. And for m3, the moment of inertia will be m3 r3 square. So it doesn't matter whether mass is on, this side or that side, like, or this side or this side. It doesn't matter. What matters is how much is the value of the mass and what is the distance of mass from axis of rotation. Okay, now there is this rod of mass m, length L, and this axis of rotation which is passing through one of its end, and we have to find moment of inertia of this rod from this axis of rotation. So what we do is, we can't calculate it easily because the mass is distributed on this rod. So for this case we will use integration. So from unitary method, since we know for L length the mass is m, for 1 the mass will be m by L, and for small length dx. So at a distance x from axis of rotation, we are taking a small length dx, small length element dx. So for this dx, the mass will be m by L into dx. So small mass will be m by L dx. And moment of inertia is what? Moment of inertia is mass. So moment of inertia is mass into distance, square of distance. So dm into x square. Dm is what? M by L dx, x square. The integration limit are from 0 to L. So m and L are constant, and x square, integration of x square is L cube by 3. The limits are 0 to L. So the moment of inertia is ml square by 3. Similarly, suppose the axis is passing through center of rod. So same, with the same unitary method we'll arrive at dm. Moment of inertia will be dm into x square, putting the values, but the limits are from minus L by 2 to plus L by 2. Suppose the length is L, so half of the length will be on the negative x side and half of the length will be on the positive x side. So the rod will start at this point. So minus L by 2 comma 0, and it will end at this point. So plus L by 2 comma 0. So solving this, the moment of inertia will be ml square by 12. So If the axis passes through side, then ml square by 3, and if it passes to center, then ml square by 12. Same moment of inertia of a rod when rod makes an angle theta with the axis. See, the mass is m, the length is l, and the moment of inertia of rod if the axis passes through the side of the rod is ml square by 3. But here we are only concerned about the length which is perpendicular to the axis, not with the length which is parallel to the axis. So the length which is perpendicular to the axis is L sine theta. So moment of inertia is ml square sine square theta by 3. And the place of L we have put L sine theta. Similarly, if we want to calculate moment of inertia of a ring, so this is a ring and we want to calculate moment of inertia about this axis, the axis which is passing through the center and is perpendicular to the plane of the ring. If we take a small mass element dm, the dm will be at a distance r from the axis of rotation. So small moment of inertia of dm will be dm into r square. R is a constant and integration of dm will give m. So moment of inertia of a ring about an axis which is passing through its center and perpendicular to the ring is mr square. Similarly, if you want to calculate moment of inertia of a disk, now in the case of disk, the mass is distributed on the surface area of the disk. So from unitary method, if we take a small small ring of thickness dr, then its area will be 2 pi r dr, because area is what, length into breadth. So the circumference is 2 pi r and the thickness is dr. So for pi r square the mass is m, 1 m by pi r square, and for 2 pi r dr, this is mass of the small ring element. The mass will be 2 m r dr upon r square. And for ring we know the moment of inertia is mass into radius square. So di will be dm into r square, putting value of dm here. So from integration we will get the value to be mr square by 2. So for ring the moment of inertia is mr square, and for this the moment of inertia is mr square by 2. Suppose now we combine all the systems. So there is a ring, this one is a ring, this one is the disk, there is a rod, and there is a mass m. And I want to calculate the moment of inertia of this full system about an axis which is perpendicular and passing through center. So there will be 4 moment of inertia. For this mass m, the moment of inertia will be mass into 2r square, because the mass is placed at distance 2r from center. For this disk, the moment of inertia will be m into 2r square by 2, because moment of inertia is mr square by 2. For this ring, the moment of inertia will be m into r square. And for this rod, see the axis is passing through center of the rod, so moment of inertia will be ml square by 12. So the total moment of inertia will be sum of all the moment of inertias.